Okay, for 13 through 15, we're looking to find the domain and write it in an interval notation. So again, with all functions, we start with the idea that all inputs will work and find the things that cause illegal operations. So for 13 here, we're going to think all real numbers, except you can see here we have a division going on, and so we have to worry about what happens when that denominator equals 0. So let's find what value causes that to happen. If I set the denominator equal to 0, x plus 7 equals 0, and if we go ahead and just solve that quickly, you get x equals negative 7. So conceptually what's going on here is all real numbers, all reals except 7 will be the domain. And then in order to write this in interval notation, though, we need to use the union symbol, or I called it the U as the glue. And we're going to take all the numbers from negative infinity all the way up to 7, but exclude 7 because it causes an illegal operation. And then we're going to union that with the right side interval, which is 7 all the way up to infinity. And if we were to sketch that on our number line, you would see that it's just 7 with an open circle and the rest of the number line shaded. So this is the domain. For 14, again, we start with the idea that all real numbers will work and figure out what will cause illegal operations. Well, here we have a square root sign, and so we have to worry about having negative square roots. Even though we know what I is in the complex numbers, since we're graphing in the real number system, we're going to only look at real values that are, we're going to think about real numbers when we think about what's allowable here. So in order for this to be valid, x plus 7 has to be greater than or equal to 0. It needs to be a positive number in order to not be illegal. And so if we solve that little inequality here, we get x is greater than or equal to negative 7, and that will be the allowable inputs for the domain. But this is asking it again for interval notation, and so we're going to start with negative 7. Negative 7 actually works. You're allowed to take the square root of 0. So we can go ahead and put that number in, and then it's going to go all the way up to positive infinity. 15 here, you should now recognize this as a parabola in intercept form. But all we're really concerned in this question is what's the domain in interval notation. Well, here we're just multiplying two numbers. Well, if we take an input, we're adding 7 or subtracting 5 and then multiplying the numbers. There are no illegal operations that can result from that. And so our domain here is going to simply be all real numbers. And in interval notation, that means we go from negative infinity all the way to positive infinity. And again, infinity is always enclosed in rounded brackets for interval notation. So 16 through 19, this is a simple classification question about whether functions are constant, linear, quadratic, or neither. Well, constant functions are easy. Those are ones that just equal a number no matter what the input is. And so we can see that 18 satisfies that idea. And so that's going to be a constant function. Linear functions have the form ax plus b, so there's an x term, and there needs to be an x term, so a can't be 0, and then maybe there will be a constant. So if we look, or another way to think about that is, is the highest power of x 1? So if we scan through these, we can see that number 17 here, there's no power written, there's an implied power of 1, and so 17 will be our linear function. Quadratic functions need to have an x squared term, and they can also have an x term and a constant term in there as well. If we scan through these here, we see that we definitely have an x squared term, and there's no other crazy terms that are part of it. And so this number 16 will be a quadratic function. And then 19, we see x in the denominator here, so we know that it's neither linear, quadratic, or constants. It's actually an example of the reciprocal function, which we haven't talked about. But in this case, we're just going to classify it as neither. For questions 20 to 28, we're going to take a look at this graph and answer a bunch of stuff about it. First question, find f of 3. So that, remember what that means. That's find the output that results when I put an input of 3. Remember, x is our input, so I'm going to find my input value and then look up and down to figure out what output comes from the input of 3. Right here will be our value. So f of 3 is going to equal 1. F of 4, we're going to find, again, that means evaluate the function at 4 or tell me what the output is when the input is 4. So we find 4 on the input side, look up and down to figure out what output, if any, comes out, and we see right here that the output is 2, so f of 4 equals 2. The domain of f in interval notation. So the domain, again, is all the inputs that can go into this function. If we're scanning across this way in the x dimension, we can see the first and smallest input we can put in is -1. If we keep going, the largest input we can put in is 7, and these are rounded brackets, so -1 and 7 are allowed to be input. So we're going to put square brackets there, so we're in -1 through 7 is the domain in interval notation. Next, find the range of f in interval notation. We're going to go through a similar process, but now we're going to think about just the y dimension here. So in this y dimension, when we're going up and down, if I start looking from the bottom up, we can see that the smallest possible output here is -1. And if we march up along, we keep getting outputs until y equals 4. So all the outputs occur between this range right here, from -1 through 4. And again, these are rounded dots, so therefore that will be included in the range. And so the range of f is going from -1 all the way up to 4, including those values. 24, true or false, the value of y is in the range of f. Y equals 5. Well, first we can just take a look right up here at the last question. We see that the range is from -1 to 4. 5 is clearly outside that range, so we're going to say false. But if we want to take a look up on the graph too, we can see that in order for y to be in the or 5 to be in the range, we have to look along this line here, y equals 5, and we see that there are no outputs that ever hit that line. And so that's another way of seeing that the answer to that is false. 25, find the x-intercept of the function. Here we're going to just take a look at the x-axis and see where the function hits. We see it right there at x equals 6. So the x-intercept of the function. Intercepts are technically a coordinate, so it's best to write that as 6, 0. And here this is a coordinate, not an interval notation range. I know it can get confusing because it looks just like it could be an interval notation. But if you wrote just 6, that'd probably be okay too. For what values of x is f of x equals 0? This is another way of saying where does the output equal 0, or what f of x is also plotted on the y-axis. Look up here where f of x equals 0. This is the output line of 0. Well, it's the same number there. It's x equals 6. That's another way of actually finding the x-intercepts. I talked about that earlier. So x equals 6 is where that occurs. So this is just, again, kind of a similar way of asking the same question. And then the last one here, for what values of x is f of x equals 1. Again, that's the output. So we're going to go take a look at the y values. Y equals 1 is along this line here. So we can see that there's a lot of spots where that happens. It looks like there's an interval here. First from 1 to 3 will give us an output of 1, and then there's a single value here at 5. So we have to get clever about how to write that. Well, we know from 1 to 3, so this is interval notation, and 1 and 3 also do give us that value of 5. So that gives us this part right here, and then we have just the number 5. And I guess officially with interval notation, the way you would do that is you're going to just union it with 5, 5. It's just a way to glue on a single value of 5. But if you wrote it, You could, if you didn't write it in interval notation, it would look something like this. X is between 1 and 3, and X equals 5. So like that would be another valid way to describe the values for which X, or the values of X that create f of X equals 1.